Namaste everyone. Welcome to our YouTube channel Ask Prep. In today's video, we are going to discuss about why do stars twinkle? A celestial journey beyond the flicker. The twinkling of stars in the night sky is a captivating phenomenon that has fascinated stargazers and astronomers for centuries. This visual effect is caused by the distortion of starlight as it passes through the Earth's atmosphere, a process known as atmospheric scintillation. As the light from a distant star travels through the ever-changing layers of the atmosphere, it encounters pockets of air with varying temperatures and densities. These pockets act like tiny lenses, refracting and bending the light in different directions. This results in the star's image appearing to flicker or twinkle, creating a mesmerizing display in the night sky. Atmospheric turbulence. One of the primary reasons why stars appear to twinkle in the night sky is the phenomenon of atmospheric turbulence. As starlight travels through the Earth's atmosphere, it encounters constantly shifting pockets of air with varying temperatures and densities, which act like lenses that refract and distort the light. This turbulence, caused by factors like wind, convection, and uneven heating of the atmosphere, creates a shimmering, flickering effect that we perceive as twinkling stars. The turbulent air in the atmosphere acts like a constantly changing, uneven lens, bending and scattering the starlight as it passes through. This causes the apparent position and brightness of the star to fluctuate rapidly, creating the twinkling effect we observe. The degree of twinkling can vary depending on the specific atmospheric conditions, with more turbulent air leading to more pronounced twinkling. Interestingly, the twinkling effect is most pronounced for stars that are closer to the horizon, as the light from these stars must pass through a greater thickness of the Earth's atmosphere. Stars that are directly overhead, on the other hand, have their light passing through a smaller amount of the atmosphere, resulting in less twinkling and a steadier appearance. Refraction of light. The twinkling of stars is primarily caused by the refraction of light as it passes through the Earth's atmosphere. As light from a distant star travels through the atmosphere, it encounters pockets of air with varying densities and temperatures. These variations in the atmosphere act like tiny lenses, bending and distorting the light from the star. The Earth's atmosphere is not a uniform, stationary medium. Turbulent air currents, temperature fluctuations, and other atmospheric disturbances constantly create regions of differing air density. As the light from a star passes through these regions, the light is refracted, or bent, in different directions. This shifting and bending of the light is what causes the twinkling effect we observe when looking at stars in the night sky. The degree of refraction depends on the difference in air density between the layers of the atmosphere. Colder, denser air will refract light more than warmer, less dense air. These fluctuations in air density happen on very small scales, leading to the rapid, flickering motion of the stars as we see them from the Earth's surface. Scintillation effect. The twinkling of stars is primarily caused by a phenomenon known as scintillation. Scintillation refers to the rapid fluctuations in the brightness and position of a star as observed from Earth. This effect is caused by the bending and distortion of the star's light as it passes through the Earth's turbulent atmosphere. As the light from a star travels through the atmosphere, it encounters pockets of air with varying temperatures and densities. These pockets act like tiny lenses, refracting and bending the light in different directions. The result is that the light from the star appears to flicker and dance, creating the twinkling effect we see in the night sky. The degree of scintillation depends on several factors, including the altitude of the star, the thickness of the atmosphere, and the turbulence of the air. Stars that are closer to the horizon tend to experience more scintillation, as their light passes through a greater amount of atmospheric disturbance. Similarly, stars that are observed during periods of high atmospheric turbulence, such as on windy or stormy nights, will exhibit more pronounced twinkling. The scintillation effect is most pronounced for stars, as their tiny, pinpoint-like appearance makes the fluctuations in brightness and position more noticeable. Planets, on the other hand, appear larger in the sky and their light is less affected by atmospheric turbulence, resulting in a steadier, less twinkling appearance. Twinkling and star brightness. The twinkling of stars is closely related to their apparent brightness as seen from Earth. Brighter stars tend to twinkle more noticeably than dimmer stars. This is because the disturbances and turbulence in the Earth's atmosphere have a greater effect on the light from a bright star, causing more pronounced variations in its perceived brightness. As the light from a bright star passes through the atmosphere, it encounters pockets of air with slightly different temperatures and densities. These variations in the air cause the light to bend and refract in random ways, leading to the familiar twinkling effect. The more intense the light, the more dramatic the twinkling appears to the observer on the ground. In contrast, the light from dimmer stars is less affected by atmospheric turbulence, resulting in a more steady and uniform appearance. The twinkling of fainter stars is often less pronounced or even imperceptible to the naked eye. This difference in twinkling behavior between bright and faint stars is an important clue that helps astronomers and stargazers distinguish between stars and planets in the night sky. Now let's talk about differences in twinkling between stars and planets. One key difference between the twinkling of stars and planets is the underlying cause. Stars twinkle due to the refractive effects of Earth's atmosphere, as their light is distorted as it passes through pockets of air with varying temperatures and densities. This scintillation effect makes the stars appear to flicker and dance in the night sky. In contrast, planets do not exhibit the same degree of twinkling. This is because planets, unlike distant stars, are much closer celestial bodies that appear as distinct points of light. The light from planets does not travel through as much atmospheric turbulence, resulting in a steadier, less flickering appearance. Planets also have a larger apparent size, which helps to average out the effects of atmospheric distortion. Another notable difference is that stars exhibit a wider range of twinkling intensity, with some appearing to twinkle more dramatically than others. This is influenced by factors such as the star's brightness, color, and position in the sky. Brighter stars and those closer to the horizon tend to twinkle more noticeably. Planets, on the other hand, typically exhibit a more consistent and stable level of twinkling, if any at all. Thanks for joining us today. We'll continue exploring the fascinating scientific facts of universe in future episodes. Until then, stay curious, stay informed, and stay safe.